Hi, Eric. Our next speaker is Arkadiusz Kalandik, though he is happy for us to call him Eric. Has been a platform engineer at Epsilon for the past 2.5 years with a strong focus on infrastructure. His expertise also extends to his role as a DevOps engineer, where he supports developers by streamlining automation processes. Outside of work, Eric enjoys riding his bike, exploring the world of books, and foraging for mushrooms when the season arrives. A wonderful reminder of balance between work and personal passions. Please join me in welcoming Arek, who will share insights on balancing automation with GxP compliance.
Okay, I guess I can start. So hello, I'm Arkadiusz Kalandek. You can call me Arek, as Andre mentioned. And today I'm going to talk about concepts that are typically related with software development life cycles or with a DevOps methodology, which are CI/CD pipelines and Git as a collaboration tool. And I'm going to put them into the GxP context. So let me jump to the agenda. So I partitioned my talk into two main parts. Obviously, I'm going to have a really short intro at the beginning, and we are going to have Q&A at the end of the talk. But my talk is separated into two parts. The first one, good Git practices, where we are going to shortly check why we should use Git at all. And I'm going to provide you some tips, some maybe good practices related with the most basic Git workflow that we are utilizing every day, and that is related with the commits. So that's something that we are going to touch that then. And the second part is going to be related with the CI/CD pipeline. So we are going to talk about good automation practices, where I'm going to focus mostly on the good structure of the CI/CD pipelines, because it's something that can affect your whole setup, your traceability of the pipelines and its execution a lot, right? It can save you a lot of time, basically, and a lot of troubles. So short intro, while we are talking about continuous integration, continuous deployment, so CI/CD pipelines, or Git as a version control tool in the GxP context, we can talk about it as a part of good software engineering practices, or to be more precise, part of those three groups that I listed on the slide that are part of GCEP. So good development practices, good software validation practices, and of course, good reproducibility practices. Automation and Git makes a huge part of in terms of those subgroups of GxP. And that's the context kind of for GxP in this talk. So as I promised, that was a short intro. And right now I'm going to jump into the meat. So we are going to start with explaining what Git is and why to utilize it. So yeah, like I already mentioned, Git is a VCS tool, so version control system tool, which allows us to track changes to our files over time. And this allows us to provide a better collaboration within our development teams because we can maintain the history of modification, history of changes. And using Git allows us to utilize its features, let's say. So for example, because of that we have a history of changes, we can jump back to a previous version if it's needed. We can always compare the changes that are being done in the multiple places, right? We can compare changes between this branch and maybe that branch. And we can also have the responsibility aspect there, as each change has its own author and its own modification time. So we can check who made the change when and who we can blame, let's say. And also an additional feature that is worth mentioning related to Git is obviously the resolving mechanism of conflicts, right? Because when we are working in an environment with multiple people, with multiple changes at the same time, conflict resolution is a very big, important part of our workflow, and that's supported directly by Git itself. Also, I think that from the GxP perspective, the most important part that gives us Git is the traceability of the changes, right? By utilizing the Git commit system, we can see what kind of changes were done, when, and by who, because we have those metadata alongside the Git commits. And also Git commits are immutable because they are having this identifier that is based on the changes itself. So it's pretty robust system for audits, I guess. Okay. In the agenda, I mentioned that I wanted to take a basic Git workflow that we are utilizing every day. Each time we are working with Git, we are doing this basic Git workflow. And I wanted to take this and provide you some good practices, let's say, because I think this is something that is actionable, right? I mean, after today's conference, you can take those tips related to the Git commits that I'm going to present, and you can introduce them right away, right? You don't have to wait for your, I don't know, IT operation teams to do something for you. You can get those tips and start using them. So yeah, maybe at the beginning, let's explain the workflow. So a typical thing that we are doing while we are developing code with Git is that we are making some changes, obviously, in a code editor, IDE, whatever place. We are selecting then the changes that we want to snapshot, so the changes that we want to save in the next commit. And finally, we are saving the changes in a commit. And below the steps, we have a screenshot where I have two commands. The first one is obviously selecting the changes that we want to commit. So it's the second step in our workflow. And we have the third one, the second command, but the third step, which is committing with providing a Git commit message. And actually, that's the part that I want to focus on right now. And you may, so I'm talking about Git commit message, obviously. And you may ask why I'm focusing on Git commit messages or Git committing at all. And that's because proper Git messages, or in general, proper Git commits can introduce it can improve our traceability via Git tremendously, right? I mean, it can improve it a lot. It allows us to easier check the history of modification and can be really useful during the audits. So at first, let's take a look at our message. Here we have fixed back and updated UI styles. The first thing that we can notice here is that we have two different contexts here, right? We have two different logical changes here included in the Git commit message. We have a fix of a bug, and we also have an information about updating the styles in our web app, I guess. So the first good thing that we should always do is that we should include only a single logical change within our commit. So what we can do here, we can split our changes, and we can add only the changes that are related to the fixing the bug, and adjust our Git commit message to just fixed bug, right? Right now we have a Git commit that has only one context, which is good, and we can work on it further. So the second thing that you may notice right now, as we just have fixed bug message, is that it doesn't provide too much context. And that's not useful, right? Because if we are going to have multiple Git commits in our history that are just like fixed bug, introduced feature, introduced bug, then it's going to be a problem, right? It's not visible, it's not readable. So what we should do is that we should provide a descriptive message to our Git commit. So for example, we can do something like that, where we are providing a pretty long but descriptive message, but it's the problem, right? I mean, it's too long for us to read it quickly. We need to process that. Even reading that is going to be painful, at least for me, so I'm going to skip reading that, and I'm just going to go straight to the point. And the point is that we should have descriptive but concise messages, right? You may even heard that some people are recommending to keep our Git commit messages up to 50 characters. And to be honest, I'm not very strict about it, but I think it's maybe a good rule to follow, right? If your Git commit message is like 52 characters, you shouldn't care that much, but it should be around 50 characters at maximum. So here we are doing a change, right, to our Git commit message. We are simplifying it, right now we have fixed null pointer exception in login. But additionally, we're providing some context in Git description with the second -m flag. But let's keep it straight, right? Let's keep the message like that. So fixed null pointer exception in login. Right now, the message is already pretty decent, right? I mean, we already know what's happening here. However, there's one style change that we can introduce here, and that's related to the verb form. Right now, we are using non-imperative verb form, but what is recommended typically is to use imperative verb form. What does it mean? It means that we are get rid of ed suffix, and we are just using the bare bone verb, right? We had fixed, right now we have fixed. I know, maybe we were using added, right now we should use add. And why we should use this imperative verb form? It allows us to have a more simple and more concrete message. And also it's shorter, right? I mean, we save 2 characters with that change. And I know that it may also seem very subjective, right? I mean, that doesn't seem very big, but in general, it helps us keep some kind of structure and gives us information about the direct action. And if you have problem with using imperative verb forms, you can always use this structure. So if applied, my commit will, and here we are putting your message. So in our case, we are having this. If applied, my commit will fix null pointer exception in login. So this is a direct action that we can see from our git commit message. Okay, let's go back to our fixed git commit message. And let's apply the last thing here. Because if you think about commits and you have a large number of them, you may think that, okay, maybe I should somehow structure them. I mean, somehow structure the messages that we are saving as a team to keep it more robust, to keep it more readable for us. And you may ask, is there any solution for that? And yes, I can say that there is already a special convention that is called conventional commits that provides you a structure that you can apply to your git commit messages. So for example, here I've already applied the structure, but if I go to the next slide, not this one, we can see the typical or the proposed structure of the git commit message by conventional commits. So typically, at the beginning, we are assigning type of our change. It can be fixed, it can be fit, feature, docs, chore, whatever we decide. Additionally, we may have optional scope. So for example, in our case, we may have auth or API, lang, or maybe any other scope that we agree upon within the team. And we are adding the description as the last part of our message. So utilizing the structure allows us to have more structured git commit messages. And because of that, we may have some additional benefits of using conventional commits. Because when we have those git commits structured, we might apply some additional automated checks or automated processes. Like, for example, we can automatically generate change logs based on the type of our commit messages, right? We can additionally, provide some kind of information to our CI/CD system based on scope or on type. And also the last advantage of using conventional commits is something maybe subjective, but I think that introducing a structure helps other team members to get the context more easily out of our history of modification. So this is something that is probably the most important, but it is sometimes neglected by people. Okay, so right now we are having 2 git commit messages here. The first one is the initial one. The second one is our final one. And I'm not sure if we can do that, but maybe let's spam a little bit in chat. And if you think that the first commit message is better because it provides you more context or is more readable for you, spam or type 1 in the chat. If you think that the second one, so our final one, is better, provides you more context, you can type 2, and I think that later on we can see which version is winning. But in the meantime, let's jump again to our basic Git workflow, and let's add additional thing to our setup. So again, we have the same thing. Right now, we are already providing some additional. Sorry, we are adjusting our Git messages, and we can add an additional thing to our setup. And that thing is precommit, which is a tool that allows us to run Git hooks, which are some kind of automated scripts that are run just before our commit is saved, right? So if we go back to our Git basic workflow, in the first step, when we are running our git commit command with our message, the git command is going to run, Git is going to run our hooks defined by precommit. And if something is wrong, our commit is not going to be saved. And utilizing precommit can help us with validating our changes in the commit that we are about to create early, because we are not pushing them, we are checking the things just before we commit that, right? Just before we save that. And we can check a lot of different things inside of pre-commit. For example, here I have a screenshot where I added a change to a GitHub Workflow YAML file, and I introduced there some bugs. The first one was related to the structure of the YAML, and the other one was the trailing space. And here we can see that when I run git commit command, our pre-commit was run, and it detects two issues, right? We have failed information about the first hook, where it identified that there is an issue with our YAML structure, and the second hook, which identified that we had issue with a trailing white space, so a space that is appearing somewhere at the end of the line where it shouldn't. And in this case, for example, in the first hook, we got the information about issue where it is, so we can go back to our editor, we can fix that, and we can then try to again commit. With the second one, we actually got the automated check that automatically fixed the issue, right? So it automatically removed the white space that shouldn't be there. So here we have the configuration of pre-commit that I used for that specific example. And as you can see, it's not complicated, right? We are just defining a repository that is an official pre-commit hooks repository. And we are defining which hooks we want to use here. So check YAML and trailing white space. And here we have the example when I've just fixed my issue with the YAML file, and I'm trying to commit it again. And as we can see, both of hooks passed, which means that my commit was saved, and I'm sure that my commit was validated, and it's good within those two hooks. And in terms of our code, we can also find some specified hooks. So here I listed just 3 of them that are available in this specific GitHub repository. And as you can see, you can, for example, check that you are not leaving any print statements in your code when you are committing, or you can run parsing of your R code as well. There are many more hooks, but I just wanted to list those 3 here. And I think that right now I can jump to the last section of my presentation, where I'm going to talk a bit about the structure of the CI/CD pipelines and all about CI/CD pipelines in general, right? Because at first, let's define what is CI/CD pipeline, and maybe define what is CI and CD at all, right? So we can define CI as a process of frequent, or maybe practice of frequently integrating our changes to our Git repository. And when we are introducing those changes, we are automatically running some checks that are checking, that are validating our code, right? So it can be building, it can be automated tests, whatever we want. With CD, it's similar, but it's about continuous deployment / continuous delivery. That part is taking care of automated deployment to our environment. And going back to CI/CD pipelines, those pipelines are simply a set of steps that are automated and that are implementing our process, right? So it's basically the recipe of our automated process that we want to run. And by introducing CI/CD pipelines into our software delivery processes, we can obviously reduce some time that is taken by typically done manual checks, manual validations, right? Right now we are putting those into the CI/CD pipelines. We can run those validations each time a new change is introduced, and that both helps us write the code more efficiently and also helps us identify issues as early as possible, right? Because if we are running validation tests right after the change is introduced, we can check if it's the good code or if it's not a good code. Additionally, we can also minimize human error, because when we are running manual validations, we are following steps, and it may happen that a person makes an error, right? Because if we are doing the same thing repeatedly, we may make an error. It's a typical human flaw, unfortunately. And with automated pipelines, we can be sure that the pipeline is not going to make a human error. Maybe it's going to make an automation error, but definitely not a human error. Okay, right now I'm going to jump to the structuring part of CI/CD pipelines. So I'm going to describe the general overview of the CI/CD pipeline again. And also I'm going to give you some context about the good way of structuring the pipelines. So a typical CI/CD pipeline consists out of 4 elements. So the first one is trigger. So our event that is triggering the pipeline execution. The trigger, it can be a specific event, such as for any change that is going to be pushed to any branch, or any change that is going to be pushed to this specific branch, or any event that is related to pull requests. So for example, run this pipeline when a PR is created. Or it can be even a manual trigger, right? Maybe there are some processes that we want to run manually. We can obviously do that as well. So we have the pipeline execution. So it's the main block, right? This is where our pipeline is being executed. So it is being run there. And this is where the whole process is automated and run. We have our outcome, which is basically the result of our execution. So we have information if everything went okay, or if there was any failure. We may obviously add some notifications, like email notifications, if there's any error. And there is fourth element, which is artifacts. And that is basically an archive, maybe. But we can think about it as a side product of our pipeline execution, right? Because when we are executing a pipeline, we may have some side products of our execution, right? So for example, here, during the build part of our pipeline execution, we are building, let's say, our R package. So as the result of building, we have the star.gz artifact, right, files, which later on we can use in the other part of the pipeline, which is deploy in this case. And the most important part about artifact is that, yeah, we can share artifact between parts of pipeline execution, but we can also have, or we have those pipelines, we have those artifacts available for us once the execution is done, right? So for example, we may have test reports that are saved as an artifact that we can later on, after the pipeline is executed, we can download them and we can use them. Okay, let's jump to the next one. Okay, so here we see an actual implementation of this structure where we are having the YAML file or YAML pipeline. That is specifically Azure DevOps pipeline, where we have a trigger. We are saying here that we want to run our pipeline each time there is a push to our main branch. And in the stages part, we are defining 3 stages. And maybe right now I can say something about stages. So if we go back here you can see that I divided my pipeline execution into 3 separate blocks under the hood. And this is the first layer of modularization, of splitting our logical segments into different parts, right? Into different blocks, into different boxes. So here, for example, we split our pipeline into 3 stages, which is build, test, and deploy. In the first part, we obviously are building our package. In the second one, we are running some validations. And in the third one, we are deploying our package on Package Manager, for example. So here we have the implementation of this pattern here. So we have stages. The first one is obviously build. Here we are running a command to build our R package, and later on we are also uploading our artifact, which is the package itself that we built. We have test stage, and in the deploy stage, we are downloading our artifact here. Okay, so I already said that we are introducing you, we are showing the first layer of segmentation or modularization. Here we can modularize it even further. So inside of stage, we can define so-called jobs. And inside of jobs, we can define, or we should define, steps. So the implementation of our jobs and stages. Okay, and why it's important to further divide our CI/CD processes. And that's because we may want to split our logic again, right? Here we are having test stage, and inside of test stage, we want to run 3 different jobs, which are, I don't know, unit tests, right? We have an example here. We may have separate job for running integration tests, and the last one, end-to-end tests, right? With this segmentation, we can run them in a separate, independent jobs. And with that, we have some kind of isolation. It also allows us to run those jobs in a concurrency, right? We can run them at the same time, which means that we can, again, save some time. And also, in case there is some kind of failure, we can more easily track what have happened, right? Because let's say that we have an error in test stage, then we can see that we have an error in unit test job. The other 2 jobs are okay. So we can jump to that unit test job, and we can see which step failed in our execution. Okay, I think that I should speedify a bit. So here we have an implementation of stage test, where we have defined those different jobs here. Okay, and the last thing that I want to touch today is the further structurization of our pipelines, or maybe I should say modularization in this case, because similarly to some programming practices or programming good practices, we can apply here don't repeat yourself rule, right? Because there's going to be a time when you want to define the same pipeline for, I don't know, 5, 6, 10, 50 apps, and you find yourself copy-pasting the same pipeline into multiple repositories. And that is a bad practice, right? Because it can introduce a lot of drifts between certain pipelines. And with this don't repeat yourself rule, you can define pipelines in a central place and utilize the template in the multiple repositories. So maybe I will try to repeat that with this schema, right? On the right side, we have package repositories, multiple of them. On the left side, we have our central pipeline repository where we keep the single pipeline template, right? And in those multiple apps or package repositories, we are referencing the pipelines that are defined in the central pipelines repository, which means that we can keep it versioned, we can keep it centralized, and it both reduces some time maintenance and allows us to reuse the same logic. Conclusions, give me 30 seconds. I will shortly go through that. In terms of Git commit messages, remember to keep a single logical change within single commit. Write descriptive and concise messages. Use imperative verb form. It's maybe subjective, but do that. And if you want to keep your commit structured within team, use conventional commits. remember that you can use pre-commit to automatically validate your commit before it's saved. And in terms of pipelines, structure them with stages, jobs, and steps. And in case you need to reuse the pipelines between multiple repositories, you can keep them in a central repository and reuse them. Okay, here I have references, and I think that we can jump to the QA section if there's any question.
Thank you, Eric, for the presentation. We may have time for one quick question from chat, if someone writes it there. But those are such good practices, and I think we are all guilty of bundling together stuff in a Git commit and some of the things that you mentioned during our presentation. If I do have one question, maybe just to quickly fit in, and after that we'll go to break. So is there a risk? Is there a risk that pre-commit will take so long that people start skipping it and avoiding the good stuff and the helpful hooks that it uses?
Yeah, I mean, it may happen that you start adding hooks that are taking a long time, right? Because, for example, you may want to try a hook that is running your, I don't know, end-to-end tests. That may be crazy, but you can do that, obviously. Nothing is stopping you there because you can also provide some custom hooks for that. So, yeah, you should be careful with the hooks that you are using. The best way is to add it and observe how much time is going to consume it. Because long pre-commit validation can introduce some friction to the developers.
Thank you, Eric. This was such a good follow-up for the first two presentations, and it will continue after the break with when talking about how to use on the impact of test automation in pharma for GxP validation. We'll have this short break, and we'll return in about 17 minutes at 3 p.m. On the CET time zone. So again, I invite everyone in the audience for a round of emoji applause to Arek, and we'll continue after the break. See you later.
Thank you. See you.